Hi, myself Ramit, and I've been a part of the Docker community, Kubernetes projects, and a lot of orchestration and playing with containers basically. So basically with the evolution of containers, certain concepts of how our architecture should be, that came into play, right? So that's what my talk would be about, and how we can build a perfect architecture or a perfect alliance of architecture that helps us grow as we scale with our code, right? So this is my talk would be about, and you might have seen this sort of architecture in various big companies, I guess. That is in Netflix, you might have seen, in Twitter, in Google itself, you might have seen such sort of architectures. So I will be going through those case studies as well, like how they did this stuff and what can we learn from them, right? So that will help us a lot. Okay, so directly, without any wasting time, I'll move to the agenda. That is why is this important and stuff. So these are the topics we are going to cover. I have introduced myself, so yeah, this is one of the most important advice I think, I guess, like that is from Werner Vogels, that everything fails all the time, and that is true. You cannot rely on anything while you are dealing with any sort of infrastructure related queries, right? So this is one of the most important piece that you have to remind yourself while building microservices. Okay, so this is important because everything is changing, right? First you have an old style of IT that looked somewhat like this, and you have a new style of IT. You want faster rate of deployment, you want faster rate of testing, you want the teams to collaborate faster and release stuff, right? That is what we want, and that is how evolution has taken place. So let me talk about a term, very simple, SOA. Basically, SOA is a 1990s term, I guess, and it revolves around the concept that, okay, you have to treat your service very importantly while building your architecture. You have a release cycle plan. Every sort of step consists of something that helps you make your code very efficient and useful for the product, right? So this is sort of a strategy and a whole lot of stuff, like how we can move from one pace to another by delivering, right? So the whole process is meant to be speeding you, right? It is meant to be automating your stuff, right? That's what the whole idea is about. So this is what happened when people starting using the concept of SOA, although at the starting, I guess, it was not correctly used how we describe SOA, but yeah, this is somewhat the change that happened when you move your services from before SOA to after SOA. You have a distributed system, to be saying in simple terms, right? You have your databases very frequently used differently by different teams and different stuff. So everything is simplified, right? Nothing is compact, nothing is very much concised these days. So this is somewhat the mythology of SOA, I guess, is there, that you have a SOA in place, but every single person has a different opinion about it. You have your end users having different opinion, you have your IT engineers every different opinion, you have your QA engineers different opinion. So everybody has different opinions on what SOA is. So first type of architecture that I'm going to discuss is the monolith. So monolith architecture says that all your services and all your stuff needs to be compacted into one database and one service for all, right? Like you have in this example, you have billing system, you have your driving system, you have GPS, and all your services stuffed via one REST API, one database, and one thing. You don't have different databases or different architectures, different complexities around it. You have one database, you have one REST API, everything is related to one another. Everything depends on one another, right? So yeah, this is somewhat a better picture of what monoliths is all about. In simple terms, you have one database,
and then you have all the configuration files, and this is a simple diagram of a web UI based like company. So you can just see that, okay, you have one database connected to all your configuration files, every layer depends on each other, and you have to do builds accordingly, right? So a little bit about microservices. This is what, like when we remodify this, refactor it basically. So this is what happens, right? Every sort of service has its own REST API, its own database, its own services. Nothing is dependent on each other, okay? So this is what, when we refactor, this is what it looks like. Okay, so the proper definition of microservices, I believe, is given perfectly by Adrian Cockcroft. He's a guy at Battery Ventures. So what he says is that it is loosely coupled service-oriented architectures with bounded contexts. What it simply means that you use loose coupling to basically transform your architecture into different components, and then you imply your stuff onto it, right? You imply bounded contexts onto it. Okay, so that is what I believe the perfect definition of it. But in microservices, one thing is common, that you got to experience it, right? So if you experience it and you feel it like that is not the way that it should be having this sort of definition, then you can, you know, type out your own definitions as well. There is no bounded context to it, like, okay. So there are two more guys in the microservices domain that you might have heard. One is Martin Fowler and one is Sam Newman. So those guys have a similar definition to microservices as well. You can see them on the websites. So this is the comparison basically between the monolithic and the microservices, right? So as you can see that we have different different components in the microservices area, and you have a single database, a single stack by stack layers in the monolithic region. Okay, so how many of you are aware about Docker? Can you answer? Okay, so as you might have been seeing that Docker is revolutionizing the IT field, right? It's revolutionizing the whole factor on how we are testing things, how we are developing things, and how faster can it be, right, in future. So a little bit about Docker. Docker is nothing but a container, right? So you bring on your containers and you test it, you build in it, and you basically have an environment running into it for yourself, right? It's a very popular project, I guess. So it's been said that it eliminates the friction between the development, QA, and the production environments, right? Because it's very simple to run. It just takes like seconds to boot up, and you have your image running and every sort of that stuff, right? Okay, the problem I believe with monolithic architecture when I speak is this. Like when you are using monolithic, you have your developers everywhere, and you have your certain language. This language should be one, like it's in this example you have a Java language, right? So they basically compile all their code and basically push it to the release cycles where you have your automation suite of tests and everything, and then you have your when it passes those tests and stuff, then you have your production environments where you can run it, right? So this is somewhat, I believe, very simple depiction of how monolithic architectures can be illustrated. This is what happens when you start using microservices. With microservices, you have the option and the liberty to use variety of different languages, right? You can use any sort of language that you like. You have your Docker container, you can run in it, and then you can send it to your Jenkins tool or your release cycles basically. And then you can forward that to production. So it is simple, it is beneficial for any sort of developers who wouldn't mind trying out something new on their own, right? So this is what it looks like when you first start adapting microservices.